Hi everyone, so today we'll be covering the two concepts that we have for spread, which is range and standard deviation. So the first thing we'll talk about is range. In simple words, it's the largest value minus the smallest value. So very simply, let's say you have this set of data, 9 is the largest value and 1 is the smallest, so 9 minus 1 will be your range. The standard deviation though, this means the typical spread from the mean. So let's say you have a set of data, you're going to find its mean, which is its average, and you're going to see how big or how small the smallest or biggest value is spread out from that specific mean. So, for example, you have two sets of data here. You can see that it starts at 5 and then ends at 15. So, from the center or the average, which is 10, you can see that there's only a difference of 5 between the average and the smallest or biggest value. However, for this second set of data, we have the largest value, which is 20, and the smallest, which is 10, and the average, which is supposed to be 10. The smallest is 0, largest is 20, and the average is 10. So the standard deviation is now 10. For that, it was 5 for the one above, but for this, it is 10. Because of that, we can understand that because of this deviation, the standard deviation for the second one is larger than that of the above one above. So, with that being said, we're just going to do a quick practice question. So, it's given us the guitar practice time in minutes for Jasmine and Pablo. They've asked you to find the range of Jasmine's practice time. So, it's going to be 60 minus 30, the biggest minus smallest value. Similarly, they have asked the same for Pablo. So, 120 is the largest and 0 is the smallest. So, 120 minus 0 would become 120 again. Then they've asked that both Jasmine and Pablo practiced an average of 45 minutes a day. However, because Jasmine's practice times are dash to 45 minutes, we know that Jasmine's standard deviation is smaller, so it becomes closer to, and so the standard deviation of Jasmine's practice times is smaller than that of Pablo's practice times. So that's pretty much it. Then we have removing an outlier. An outlier is a value in a data set that significantly differs from the other values. So the effect this has on the range and standard deviation is that the inclusion of outliers increases the spread of data, which leads to larger range and standard deviations. Conversely, when you remove outliers, it decreases the spread of data, which leads to smaller ranges and smaller standard deviations. So an outlier can significantly skew the mean of his data set. For example, in this one, we can see that 100 is far away from 3, 5, 7, and 10. So it's an outlier. It is significantly larger than the other values in the data set. So if we include the 100, the mean of the data set is 22. Now, notice that the mean 22 is greater than 5 of the 6 values in the data set. But if we remove 100, then the mean becomes 6.4. So the removal of an outlier is guaranteed to change the mean. If there's a very large outlier and it is removed, then the mean of the remaining values will decrease. If there's a very small outlier and it's removed, then the mean of the remaining values will be increased. Then you have the effective median. So now when it comes to the median, what happens is that if we remove 100, the median of the remaining values is still 7. So because the median is based on the middle values of a dataset, an outlier will have no effect on the median. If a very large outlier is removed, the median of the remaining value will either decrease or remain the same. If a very small outlier is removed, the median of the remaining value will either increase or remain the same. So basically, that is gonna happen if it's like far from the main piece of data. However, it can still change the values if there are very little amount of values present. So, furthermore, I'd like to mention that it's not like the change is guaranteed. There's some chance that it might, there's some chance that it might not. So it's based on that specific kind of data. So now this dot plot above shows the height in inches of 20 elementary school students. And so if you count this entire number, so it becomes 1, 2, 3, 4, 5, etc. This total number of dots is 20. And these are representing the number of elementary school students. If the shortest student is removed from the dataset and the summary statistics are recalculated, who is the shortest student? We have 42 as the outlier. How would they compare to summary statistics for all 20 students? So basically, the mean height of the 19 remaining students would be dash to all 20 students. So what happened is that because it's a very small outlier, the overall mean would increase. So the mean height of the 19 students would be greater than that of all 20 students. Now, for the median height of the 19 remaining students, what would happen? They will be the same as. And the range of the height of the 19 students would be dashed to all of the 20 students. So let's say the highest was 51 and the lowest was 42. So 51 minus 42 would be 9. But if you remove 42, then it becomes 46, and 51 minus 46 is 5, right? So the range of the height of the 19 um, would be less than. There you go. So that is your question and its answer. Now we're going to move on to the next video.